In this example, I'm going to be showing how to calculate the accumulation number for a collection. So this is based on our weekly assignment that we did last week in week 1, but I know that some people had some questions about how to do it correctly and wanted to make sure that they were completely clear on the concept before moving on to this week and next week's assignments. So I'm going to use the data set that we used in class, the Pokemon Go data set that I collected in my own neighborhood. So you've probably seen it before, but I just want to make sure that everybody knows how the accumulation number is calculated. So we're looking at the data set here. In our first column, we have our Pokemon species. So these are all the different Pokemon that I saw while I was walking around in my neighborhood for about 3 hours. The next column is the specimen number. So this is just a running total of the number of Pokemon that I've seen. So it goes up by 1 each time I see any Pokemon. It doesn't matter what kind it is. So if we scroll down, you can see that the specimen number just increases numerically all the way through the data set. And then we can go all the way down to the bottom here and see that there are a total of 282 specimens in this collection. The next column is the one that we're interested in. So this is the accumulation number. And so the accumulation number is a running total of the types of Pokemon that we've seen. So what we're interested in is how many different species we see in a given sample size. So I'm going to show how to calculate this for the first 20 Pokemon that I saw during my collection. This first one is the first Pokemon that I saw, and it's also the first type of Pokemon that I saw, so the accumulation number for this is going to be 1. This one, Wurmple, is the second Pokemon that I saw, and it's also the second type of Pokemon that I saw, so that's going to be a 2. And we're going to keep going until we encounter a Pokemon type that we've seen before. So this is 3, 4, 5, 6, 7, 8, 9, 10. In the first 10, we've seen 10 different types of Pokemon. So the accumulation number and the specimen number are the same at this point. But when we get to the 11th Pokemon, Apom, I've already seen one of those before. So the specimen number is 11 because we've seen 11 total Pokemon, but the accumulation number is going to stay 10 because it's not a new type. Okay, so let's keep going through here. That's a new one, so that's 11. 12, 13, and then we see another one of these. So that stays at 13, 13. Fungus is one, I believe, that we've seen before, yes. So that's going to stay 13 again. Bidoof, that's also one that we've seen before, so that's going to stay at 13. Venipede is a new one, so then our accumulation number goes up to 14. 14. Yanma is a new one, so that'll go to 15. Ghastly is a new one, so that will go to 16, but Weedle we've seen before. And I'm going to stop here at 25 with Lilliput, which is a new one. So let's scroll down a little bit here. So you can see in the first 25 specimens that I've identified in this collection, there are 17 different species present. If we wanted to graph this, it's pretty simple. You're just going to graph the specimen number to the accumulation number. So we can insert a chart, and it will look something like this. So you can see that the specimen number is down here on the x-axis and the accumulation number is on the y. Every time you see a new type of Pokemon, the accumulation number will go up. So if each new specimen that you identify is also a new type, your slope is going to be a 1-to-1. And then when you encounter a specimen that you've seen before, you'll have a little plateau here. So in this, first 25 specimens, the curve is continuing to increase throughout. There are a couple of plateaus here, but it's generally still climbing. So if you were to look at that and think to yourself, how do I feel about my sampling completeness? Do I feel like this 25 specimen collection represents the true diversity of Pokemon in my neighborhood? You could look at this curve and say probably not, because as I'm encountering new specimens, I'm still seeing a lot of new types of Pokemon. Okay, so this is of course a fake collection. This is not a real ecosystem. This is not a real assemblage of fossils. And there are hundreds of Pokemon, apparently. I'm not a Pokemon expert, but it seems like there are hundreds of them, and you can spend a long time looking and still find new types. So in this imaginary ecosystem of Pokemon, you would need a really big collection to sufficiently capture a picture of what the true Pokemon diversity looks like. Let's flip over to a real data set. So we'll go here and look at this mistaken point example, which I created for you before. And so mistaken point is a famous Ediacaran fossil assemblage in Newfoundland. And these data come from actual bedding planes in the outcrop in Mistaken Point. So this is the assemblage. This is a true assemblage from a single bedding plane in Mistaken Point. And these taxa that you have listed here are actual Ediacaran fossils. Some of them have true names like Charnia, and some are descriptive like ostrich feather. So this is a fossil that looks like an ostrich feather but hasn't been formally identified or is being used to sort of describe a suite of similar organisms. So anyway, I've already calculated this data set out, and you can see the sample number is the size of the collection. And if we scroll down here, there are 302 specimens identified on this bedding plane. The accumulation number is shown here, and just like with the Pokemon Go dataset, the increases by 1 each time we encounter a new taxon. So Charnia 1, we see another Charnia, accumulation number stays at 1. Then we see an ostrich feather and it goes up to 2, but we see several other ostrich feathers in Charnia as we go through this data set, and it's not until we get to our 14th specimen that we see a new type, and that's something called a frond. And so there aren't actually a lot of different types of fossils in this collection. We actually only have 8 total different taxa represented here. So if we look at this curve, it looks really different from the Pokemon Go curve. We have a steep increase at the beginning until we get to about 50 specimens, and then a large plateau. And we don't encounter another specimen until we get to almost the 150th specimen in the collection. And then we have another large plateau until we get to over 200, when we see our final 8th type of organism preserved in this bedding plane. And then we go all the way up to 300 without seeing another one. So the idea with looking at an accumulation curve like this is to understand how well you've sampled a bedding plane. And so this one has captured almost the total diversity of the whole bedding plane by the time we get to the 50th specimen. So you can take kind of a snapshot and look at a collection and say, I'm going to randomly sample 50 specimens, and that's going to give me a pretty good idea of the diversity of this bed. When you're comparing many different collections, so if you, for example, have 100 different bedding planes and you want to compare the diversity of the bedding planes to each other, you don't want to spend the time to identify every single organism preserved on every single bedding plane, because there might be thousands of specimens. So you want to be able to take a small sort of snapshot and have a pretty good feeling about your picture of the diversity. So in that case, you might take these sort of 50 specimen small samples. On the other hand, if you were interested in studying Ediacaran ecosystems in general, these are really important ecosystems. They're some of the earliest animals preserved in the fossil record, and those rare taxa are really important. Then you're going to want to go ahead and identify the entire collection and make sure that you didn't miss anything, and that there's not some single specimen that's the only representative of its kind on that bedding plane or even in that whole region. So this type of analysis is more useful when you're doing sort of big paleoecology questions where you want to compare lots of data rather than thinking about individual rare types. So that's the overview, and let me know if you have any other questions.